Lesson 46, the triangle similarity, AA, SSS, and SAS. So the AA similarity postulate, and I use the little similarity symbol so we don't have to write it out every time. That just says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar.
Didn't we already have this lesson?
No, I think we had
Because we've already done that.
for similarity.
Oh. Not similar.
Okay. So in similar triangles, all three angles are congruent and the sides are proportional. So just because angles are congruent, I mean, if that's all you know, or the angles are congruent, then all you know is that they're similar. You
only need to have two angles congruent to show that they're similar?
Yep, because of the triangle angle sum theorem,
Oh, okay, yeah.
the third will also be congruent.
So you'd only have to say the angle, not just, you
Si-
don't have to say the angle, angle.
Right, right. You would just say the AA similarity postulate. Yes, Dixon.
Is there some way we can change lines, like B and C?
Oh yeah, you could turn off one switch by the door, one by the door. So we're going to do an example. Show that two triangles, MNO and MPQ, are similar
No, that's first.
okay. If segment PQ is parallel to segment NO, then find the measure of segment PQ. So we have to have a figure to do this. Okay, so first we're going to show that these two triangles are similar. We're going to say that angle M is congruent to angle M by the reflexive property. We can say that angle O is congruent to angle PQM. And that's the corresponding angles postulate. So triangle MNO is going to be similar to triangle MPQ by the AA similarity postulate. Then to find PQ, we can set up a proportion and say 15 is to X as, and then we're going to do 15's from the big triangle. So we need to do the whole side MO, which is 12 to 8. Yep. So we could do 15 times 8 divided by 12 and then reduce. 3 goes into 15 5 times into 12. 4 goes into 8 twice. So X is 10. So PQ equals 10 units. Okay, that's the AA similarity postulate. Then we have what's called the SSS similarity postulate. Actually, it says theorem in our book. Yes, Ben. I know.
Okay, So, what makes it so that the SSS and the SAS aren't like the same as the congruent?
Okay, so when in the SSS similarity theorem, it just says that the sides will be proportional to the sides in a second triangle.
Okay.
So, they're not congruent, like in the congruence
Yeah.
theorem, I think, it's theorem or postulate. Okay. If the lengths of the sides of a triangle are proportional to the lengths of the sides of another triangle, then the triangles are similar. Okay, so here's an example. We have triangle ABC, and then triangle DEF. Okay, so we can show that triangle ABC is similar to triangle DEF by showing that the sides are proportional. So we can say AB to DE equals 3 to 4.5, which equals
1.5.
2/3. Let's see. If we times this by 10, it's 30/45, so 2/3. 2/3. Oh yeah, because 1.5 goes into both of those. Okay. And then we would show BC to EF, which is going to be the same thing. 3 to 4.5, which is 2/3. And then we show the last side, AC to DF, which equals 4 to 6, and that's also 2/3. So since, I'm not going to turn the page, I'll do it over here. So since AB to DE equals BC to EF equals AC to DF, by the SSS similarity theorem, the triangles are similar. Oops, D. And then there's one more. Yeah, we'll probably do it for practice. Okay. So we have one more called the SAS Similarity Theorem, Triangle Similarity Theorem. And that just says if two sides of one triangle are proportional to two sides of another triangle and the included angles are congruent, then the triangles are similar. Oh, it's just the included angle, huh? Oh no, because there's two triangles, okay. Then the triangles are similar. So we're going to do another example. So we want to prove that triangle SRT is similar to triangle VRU. So we can start with the included angle, angle R. It's going to be congruent by reflexive property. And then it's given that RV, segment RV is congruent to segment RU. And VS segment is congruent to UT. So we can show that the ratio of RV to RS is equal to RV divided by RV plus VS. And the ratio of RU and RT, that would be RU to RU plus UT. And because RV equals RU and VS equals UT, these you can substitute and the ratios will be equal. So by substitution, the proportion of the ratios is equal. So then you can just say by the SAS similarity theorem, the triangles are similar. And that's the